So let's make a distribution to chit-chat about as far as this goes. So everybody stat edit. Now I know the lists aren't named, but what we'll do is, since we're interested in the number of heads that we got, we're interested in what's the chance of getting heads on a coin spin. I picked that kind of arbitrarily. I mean, there's heads or there's tails. And if you know what the chance of heads is, you know what the chance of tails is automatically, don't you? Did anybody get a coin to stay up on their edge the entire time? That's happened once in like 100,000 tries, so I just pretty much rule that out. I should do it with nickels. I wonder if nickels would show up on their edge sometimes. It'd be fun. Yeah, regardless, we do it with pennies. So what L1 is going to be is, we're going to define that to be the number of heads that we got out of 10. So each of you got a certain number of heads out of 10. What are the values of that going to be? From least to greatest?
0 to 10.
0 to 10. This sounds like binomial, doesn't it? Well, actually, it is binomial, isn't it? You either got heads, or you didn't. Well said, or you didn't. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some of you might be wondering, Rule, why the hell don't you just use that wonderful binomial program you gave us in 243? Anybody wondering that? It's a good wonder. Cassie's like, no, I'm not wondering that. Why am I not wondering? Good, thanks, sister. Why can't we use the binomial program?
No, my child's over.
Say that again. Who said that? That sounded brilliant. Amaya, go!
We don't have a probability.
Because we don't know the probability of heads, right? We think it might be a half, but we don't know what it is for sure. If we put a half in there, it's going to draw us a perfect bell curve with 5 in the middle. But that doesn't. That rules out the point of doing the experiment. I mean, without the experiment itself is the point of discovering what the probability is. 0, because you could theoretically get no heads. You get all tails. I mean, Melanie was well on her way to getting no heads. Right? Did you eventually get some, Melanie?
I only got 2.
2. But 0 is a possibility. Just like 10 is a possibility. So there's 11 possibilities of what can happen. So what I want to do now is let's just go around the room and collect your data in L2. This is just going to be, for right now, it'll just be a frequency column. We can turn it into a probability distribution if you want to. I don't think there's a need to. We can just use it as a frequency. Cool? All right, good stuff. So, anybody get no heads at all? No heads whatsoever? No, nobody got that, all right. Anybody get 1 head, 9 tails? We got one of those. Amaya, thank you very much. I know Melanie got 2 and 8. Anybody else get 2 and 8? We got Melanie, Blake, and this is McKinnon. Thank you. McKinnon, Blake, Melanie. There's 3 that got there. 3 heads and the rest tails. So 3 heads. We got Joe, we got Rach, 2 in there. Beautiful. 4 heads and the rest tails. So that's 1, 2, 3, 4, 5. Keep up. I'm sorry, I lost count because I'm me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, beautiful. Half and half! Which would be kind of like the point. If we thought it was half 50-50, we should have like a mode here, I would imagine, or a meeting. 1, 2, 3, 4, 5, 6, 7. 6 and 4. 6 heads, 4 tails. 1, 2, 3, 4, 5. There's 5 of those.
That was me.
That was you too, Cassidy! Sorry, do 6 heads and 4 tails again just so I can count again. I want to make sure I count this right. 6 and 4? I did count it right. Okay.
Looks like a bell-shaped curve.
Good! Good! That's worth something. That's worth something. We're going to graph it here momentarily. 7 and 3. 1, 2, 3, 4. There we go. 4. 8 and 2. This is the converse of what happened to Melanie. There's 1 back there with Carly. 9 and 1. And 10 and 0. Okay, we got ourselves some data, friends. We got ourselves a little bit of data. A little bit of data. So what I want to do now is I want to look at this, and this is more practice for what we've got ahead of us. I want to make a histogram of this. I want to make a histogram of this. I want to get us used to looking at histograms again. I know we were doing a lot of that in 243. I don't know how much of you guys did it. That's okay if you didn't. We'll do it tons in here. I like looking at histograms of data because Nick, as the numbers went, he's like, looking like a bell curve. I want to make sure we can get that look at any time we need to. So there's 2 ways you can do that right now. If you have my programs from last term, you can run dist draw. But if you don't, which I'm assuming some of you guys don't have the programs yet, I'll give them to you later. Let's all run it from second y equals. Second y equals, we're going to run some stat plots. Remember this from back in the day? Second y equals, get you into this menu. Don't worry, you'll have many, many bad dreams about this again. Okay, I'm going to erase this distribution here. Second y equals, grab plot number 1. Let's turn it on. What kind of graph do you think we should look at? I think a histogram's a pretty good idea. I think a histogram's a great. We can actually slap a box plot too if you wanted to, if you were worried about outliers. We can worry about that later. So I'm thinking a histogram's the way to go. Yeah, I think a histogram's beautiful. X list?
L1 and L2.
I think definitely L1 for X list, since that's where our variables actually were, the number of heads. And then the frequency is going to be L2 for sure. Beautiful. Ready to go? Let's take a look at it. What's the easiest next set of button pushes to take a look at it? Maybe. Zoom 9's probably the best. Do you remember why? Do you remember why? Yeah, graph is fine if your window's already perfect. I'm betting the window sucks right now. I can try it if you want. I can try pressing graph and see what happens. Yeah, it sucks. So, Zoom 9. And what Zoom 9 is it's the Zoom stat window. Linda, you getting an error?
No, I have the box thing too.
That's okay, you still have it turned on from last time. That's okay too. You had an L1 and L2, probably from your last exam, when I had you draw the box plot and the histogram. That's cool. We can add it later, that's not a problem. That's what mine looks like, kind of like it's flipping you off. That's right. What I want to do is, I want to make it more of a dot plot. So right now, I like, as you remember from 242, I like finagling with the graphs a little bit. If you press the window button right now, the mins and maxes are a little bit weird because the TI decides how wide everything should be. I like messing with that a little bit. So I'm going to leave X min at 0. I think that's great. Do you remember from 243 what I'm going to change X max to? 11. Now, you might think to yourself, why the hell are you going to go to 11? Other than it's 11. But when the max was 10, why go to 11? Do you remember the reason for that? Because to count that, the TI needs at least one unit of space to count something. So if you go to 11, the 10 column will actually show up at the far right because it goes 10 to 11. Now we don't have anything in that space. There was a 0 in that space, but at least now you'll see all 10 spots. You need 11 fence posts to have 10 fence regions. Think about putting a fence up in your yard, right? You have to put a post, put a post, length of fence. Post, length of fence. Post, length of fence. You have to end with a post. Otherwise your last piece of fence is going to fall down. That's what that is that last post. So the 10th post and the 10th piece of fence is going to do that. You have to put that one more fence post on to kind of keep it. Does that make sense-ish? I keep talking about things like tools and skateboards and phones and fences. I hope that, see the parallels. Okay, beautiful. How about X scale? What does that control? Do you remember what X scale controls? That's exactly right, Joe. It's how wide the bars are. I like to, whenever I can, make it. I like to make it 1 if I can. 5, if I do it with 5, I'm going to have 2 bars. 0 through 5 and 5 through 10. And that's okay, maybe, but that's going to be kind of boring to look at because I'm going to lose Nick's bell for sure.
So if you had 100 to 5.
I think 5 would be more logical because then you go 0, 5, 5, 10, 10, 15, 15, 20. If I go by ones though, I actually have each bar representing each number, so 0, 1, 2, 3, 4. If I break that down too much, I'm going to lose. You saw what happened. We only had 5 bars, I think, on that last graph because we lose the distinction between the categories. Now I think we're good. Now I think you can just press graph. Don't press Zoom 9 again. If you press Zoom 9 again, you're going to lose all this work you just did. Just press graph at this point. Ho-ho! There it is. There it is. Shh. This looks like a bell curve, doesn't it? Kind of like a bell curve. So we can put some numbers on. Here's the frequency axis. And Excel would do a little bit of a better job because it would actually have numbers on each bar. But whatever, we can add those. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is the number of heads that we saw. It's the number of heads that we saw. And you can trace through if you want and actually find the numbers of those numbers of heads that we saw. Figure it out. So what do you think? On average, how many heads did we see? On average, how many heads did we see? I vote for 4. If you're saying 4, what are you using as an average? Which would be the? Well, it could be the median. It's definitely the what, though, if you're using the highest bar. It's definitely the mode. So average number of heads out of 10. If you use the mode, you're going to call that 4. 4 out of 10, which would be 40%. So there's one answer for what is the probability of heads when you spin a coin. One answer is 40% because our modal average was 4 out of 10. Somebody said median. What is the median of this? Is it also 4? It's 4.5? Are you thinking median or average at this point? Right. Now, it would be helpful if the TI actually gave us numbers. It doesn't, unfortunately. So what we could do is we could run one of our stats if you want to get those values. It won't give us the mode, but it'll give us everything else, won't it? Let's do that. It's a good review, right? Remember how to get your statistics that you need? Stat. Calc. 1 bar? It's only 1 bar, right? Even though we have 2 columns, it's still one variable, the number of heads. So 1 bar? Right. Don't just press enter right now. Otherwise, you've totally negated the point of doing your experiment. If you just press, I mean, you can press enter, it's going to give you numbers. It's just going to be wrong. They're going to tell you the average is exactly 5. That's because it's looking just at L1, 0 through 10. It's ignoring all those frequencies you put in. That might not be the same. So what you want to do is you want to make sure you do one of our stats, and you guys were actually describing it over there to me. What do you do next? L1, comma, and then L2. What this does is it takes the data out in list 1 and puts the weights in list 2 with the data. So it doesn't count 1, 0, 1, 1, 1, 2, 1, 3. It counts no zeros, no, I think maybe there's 1, 1, however many 2s, however many 3s, however many 4s. It keeps track of all of those. That make sense? Now let's see what it is. Aha, it's a little bit below 5, 4.7. So by average, we've got 4.7 heads out of 10, which would be 47%, if you turn that directly into a percentage. A little bit different than 40%, a little bit below 50%. Although Alan's going to say, wait a minute, rule? If you're going to talk about the average, what else should you talk about? What else should you talk about? You mentioned it about an hour ago, Linda. Standard deviation around that average. Yes, there's a spread. There's sampling differences. So you might want to come down here at the standard deviation to 1.6 and maybe change that to a decimal 2, 0.16%. And then say it's plus or minus 16%, which seems a little extravagant, actually. That is pretty extravagant. But we'll come back to that, because that's not what statisticians do. They do something different to measure the variation. So let's just think about center for now, just center. How about the median? You guys kept talking about median before? What's that bad boy?
5.
It ends up being 5. It ends up being 5. So your median is 5. Your median is 5. Which would be 50% on median. Which one do we use? We use the average? Do we use the mode? Do we use the median? I have a vote for average. You like the average? It's good. We average? Who says average? Use the average. Who says average? Use the average. Good. Who says use the median? Nobody. Don't vote for the median. Or one vote for the median. You don't know. Good. Who doesn't know what we should? Let's start with that. Who's not sure what we should use? That's a good answer. That's a very, very good answer, actually. Who says average? Yes, average. Okay. Who says median? Who says mode? Okay, so a lot of love for the average, maybe a little bit of love for the mode. Definitely a bunch of I'm not sure. Give me some concerns for each of those things. Like, for example, a lot of love for the average. Is there any concern that you would have using the average in a sample of data?
Because it's a 50-50 chance of getting
And say that again.
outlier.
If you have any outliers, you might want to watch using an average. And why is that again, remember? Outliers pull averages, don't they? I'm going to go ahead and slap a box plot on top of this histogram to see if there's anything that measures as an outlier, if it's okay with you guys. So I'm going to turn a second plot on. We were doing this a lot in 244, or 243 at the very end, 2 plots at a time. So just to see if anything potentially might be yarding data to one extreme or the other. Let's change this to L1 and L2. And then I'm thinking you probably just press graph again, and it'll just plop the box plot on top. Any outliers?
No.
Not shown by box plot. If we would see them if there were. We're getting a little bit interesting down here, but not far enough to be measured as an outlier. You have to do that 1.5. So it must be close enough in to not count as one, assuming I turned the right thing on, which I didn't.
Sean,
Hold that thought for 1 second, Lynn. Give me 1 second. Nick, go. What's on your mind?
I was just going to say that if there were outliers, could we just do a trim?
Oh, good. Yes, absolutely. There's one small problem. Did everybody hear what Nick said? It's a very good question. If there were outliers, can we just do a trimmed mean? The answer is yes, of course you can. The secondary answer to that is I wouldn't inferentially. Remember the difference between 243 and 244. 243, you get the whole deck. 244, you get a sample. So you get a sample. You can trim the mean off. The problem with trimming the mean off is the trimmed mean isn't going to target the trimmed population mean, as well as the mean targets the population mean on average. So that's where you want to be careful. Certain things come over to inference better than others. The trimmed mean, unfortunately, isn't one of them. Thank you for that question. Let me go ahead. I'll get to you in 1 second, Mikey. I promise.
When I was at the tutoring, they said that if you do the second, where it actually shows outlier.
It does. You can press trace when you're graphing.
When you're in the box plot, doing
Uh-huh.
the plotting.
That's what, if there was an outlier there, it would show here.
Well, it was the other one that actually.
All we're saying here is there aren't any. I mean, there might be some. I mean, if you do, let me see if I can force one to be here real quick. Suppose there was one. Let's throw like maybe one down here.
I think my question is, there's a difference.
Oh crap! Yeah, there it is. Actually, it's down there. If there was one, it would show it. It's just our data doesn't have it. Is that what you're asking?
No, I'll talk to you.
Are you okay? Is it a tech question? We can do that after class for sure. Okay, let's do that. Mikey, go, sir.
Oh, just that my box plot looked different than yours, and I don't know what I did wrong.
It did.
Yeah. Well, I was like trying to do it, and
Oh,
I totally got
can I see
lost.
real quick?
Yeah.
Let me see real quick.
Yes.
Oh, it's right here. I can see the problem. It should be L2 for the frequency.
Oh, okay.
There you go, brother.
Perfect. Thanks.
Looking perfect. Yeah, you gotta make sure. You probably look perfectly symmetric, didn't it?
Yeah.
0 to 10 with 5 in the middle.
Yeah.
You have to have L2 to weight it properly. And you can see what's happening with this one. This is heavier over here than this is down here. And that's why I like having this with the histogram. Is because we were heavier over here than over here, yes? So that's indicated up here in the box. This is the middle 50% of the data, which is between 4 and 5. Hopefully that makes sense to you guys. So that's why the median and your average and your mode are hovering around 4 and 5, is because that's where the typical data is. Yours was hovering exactly at 5, maybe even going over 6, because it was balanced that way. Good! So gut feelings right now, as far as what percentage heads should we be getting on coin spins? Close to 50? Is there any suspicion that it is under or over 50? Significantly? It could be. Any gut feelings right now that's saying it's different than 50%? Anybody saying that right now? Yeah? Maybe? Oh, Ola, right? Ola, yeah, she's saying under or over, my friend? Under. Ola says, it might be under. It might be under 50%. If it were perfectly 50%, we should be seeing, as Nick said, a bell curve like that. Now that bell curve would spike at 5. Ours is spiking close to 5, but the question is, define the word close. Define the word close. How close is close enough? So here, I asked the question, what would you use? The average, the median, or the mode? Guess what the right answer is? None of them. They won't use this. They won't use these 3 things. They will take all of your results and throw them all together into a pot. So, here's what I want to go back to the TI real quick. I saw a little fist bump back there. Very nice. It was very nice. You guys said something else, didn't you? Good for you guys. Good for you guys. So,